Hello, my name is Gabriel Zavala, and my team is David Barahona and Regan Spiritus. Our product owner and mentor is Dr. Ananda Mondao, and our instructor is Dr. Masood Sayedid. We work on the app development for analyzing biological network, which is SciFinder, a plugin for Cytoscape. The software component, Cytoscape is an open source software platform for visualizing and incorporating complicated network with any type of attribute data. SciFinder is a Cytoscape plugin. SciFinder is used to locate biomarkers in disease network by locating various type of subnetworks. And a software finder, the project providing the logic behind SciFinder's algorithm. Uh, the problems we face this semester, we have three main goals. Improve current algorithm 3 and 4 by adding a threshold in code length and adding randomization to algorithm 4. Add support for directed weighted network in map equation and infomap algorithm. And number 3, complete implementation of infomap algorithm by adding other algorithm from the paper mapping hiding order. Directiveness and custom styles. This is a solution for adding support for directed weighted networks. This is part of the front end, so this will be visualized while running Cytoscape. As you can see, it has a method name, its parameters, the process, create a visual style, a name, node configurations. We have the shape, the size, and color and label of the node, the edge configuration, which are the lines or in this case arrows. We have the target and width and a color and the return value, which is the target or the biostyle. A wishes item was modifying network view displays. We explored Cytoscape documentation and implemented a visual map to give SciFinder a star reflective of biological networks. I'm gonna play a video so you can so you can visualize it better.
We transformed the Cytoscape experience, for those with SciFinder, to experience their graphs with a style that matches biological network representation. We believe that users will appreciate this modification and that future developers may expand on this further.
Now I'm gonna give you an insight of the bit length uh, before talking about the code length threshold. The previous team developed a crucial component such as the bit length calculator and the best bit length. Bit length calculator, this component actively calculates the bit length, reflecting the information needed to describe a random walker path through network communities. It achieves by evaluating various nodes model configuration within the network, guiding the algorithm towards an efficient community structure. The best bit length is continuously updates to the lowest bit length found during the algorithm iteration. This process involves comparing each newly calculated bit length with the current best bit length and updating it if a lower value is found, ensuring the search of the most effective community structure. Now I'm going to talk about the code length threshold in algorithms. The introduction of a code length threshold. This threshold acts as a stopping point for the algorithm when the best bit length falls below this threshold. It signifies that an efficient community structure has been found, streamlining the algorithm by preventing further unnecessary computation. Setting this threshold allows the algorithm to stop searching for a better community structures once it has found one that is good enough, which can be important for efficiency, especially in large or complex networks. The blue lines in the chart represent the code length as it varies over iteration. This could represent the bit length in the clustering algorithm, showing how it typically decreases as the algorithm progresses. The red dashes lines indicate the threshold level. This is the this is the predefined code length threshold below which the algorithm considers its results to be sufficiently optimized. Now adding randomization. Adding randomness to an algorithm helps it avoid getting stuck in a good but not great solution. By constantly changing how it looks at the problem, this makes the algorithm more likely to find the best solution and works well in different situations. This was done by calling the collection.shuffle method from the Java API collections that randomly permute the element in the list it received as an argument. By shuffling this list, you ensure that the nodes are optimized in a different random order in each iteration. By comparing these two charts, we can visually appreciate the impact of randomizing the nodes processing order. The randomized approach, as the spike in the second chart, enhances the algorithm's ability to explore the solution space more effectively, increasing the chances of finding a better solution. Now, an insight and introduction of the InfoMap. An overview. InfoMap is a stochastic and efficient search algorithm designed to identify the optimal model description of network flows based on the map equation. How it works: each node starts in their own module. If the node if the node decreases modularity, it is moved to its neighboring module. The process continues until no further improvement is possible. This is the picture is a representation of how it works. In it, the node 4 is moved to its neighboring module. Implementation of the fine-tuning algorithm, which is the algorithm we decided to add to the InfoMap and map equation algorithm. Overview. The fine-tuning is one of the different algorithms of InfoMap. Its goal is to optimize the modular description of network flows by allowing individual modules to move between modules. Implementation steps. InfoMap reassigns each node to be the sole member of its own module to allow for single node movement. Step number 2 moves all nodes back to their respective module of their previous step. And step number 3 recode the cluster algorithm, which algorithm 3, which is called repeated node aggression. And the picture is the pseudocode of the fine-tuning algorithm from the mapping higher order paper. Requirements to run SciFinder. Java 11, the plugin was written using Java. Apache Ant used to create the jar files, and Apache Maven monitoring the project's build, and Cytoscape 3.9.1, the software the plugin it is used in. Of a reference are mapping higher order network in memory and multi-layer networks with InfoMap by Elter, Bolin, and Rosval. The map equation by Rosval and Ecton, and the map equation software package available at mapequation.org by Elter, Homer, and Rosval. We hope you guys enjoyed the presentation and hope you have a great time. And thank you.